Hi everyone. So today our group is going to present about high density battery packs. The group members are the first one, me, Haifa Nabila binti Shahrudin, followed by Nokuratu Aini binti Noarzman, Q Sharaman, Nisa Nurani binti Muhammad Asmadi, and lastly Nurul Izzah binti Ramli. So high density battery packs is actually a lithium ion battery, which is a type of rechargeable battery that powers up starting from electronics to electrical vehicles and mobile phones. It started with these three global scientists, Stanley Willingham, John B. Godino, and Akira Yoshino. So the first one, at late 1970, Mr. Stanley uses a combination of titanium disulfide and lithium metal as the electrodes, but the combination poses serious safety concerns in the experiment, which is why it was halted. The next one is John B. Godino, which he changed the experiment at 1980 by using lithium cobalt oxide as the cathode instead of titanium disulfide, which amazingly caused the battery to double its energy potential. Now this will be one of the basic that's used by Akira Yoshino from Japan, where he used a carbonaceous material that is petroleum coke, which is revolutionary because the battery itself has proven significantly safer without the lithium metal, and the battery performance is more stable. Thus, it becomes the first prototype of lithium-ion battery. Mechanicals engineers and chemical engineers nowadays uses this space of lithium-ion research to expand the envelope of the battery performance, efficiency, safety, and even longevity by using the electrochemistry-based models for battery control. This contribute generously to the production of eco-friendly and electrical base. The first example and the most obvious one is of course Tesla. More lithium-ion battery-powered machines are being developed every single day.
Now, I will be talking about the engineering ethics behind high-density battery packs. There are multiple codes of engineering ethics. However, there are certain articles or rules that every code of ethics follow. Pictured below are three examples of organizations that provides a code of engineering ethics for their organization members to follow. From left to right, Board of Engineers Malaysia, the National Society of Professional Engineers, and finally, the American Institute for Chemical Engineers. Now, the first code of ethics or rule that I'll be touching on is environmental protection. Environmental protection is a common rule that all professional engineers should follow. The invention of high-density battery packs helps us protect the environment because they are long-lasting and rechargeable. This means that we get to reduce the number of times we have to replace the batteries, which in the long run allows us to use lesser batteries and reduce the production of new batteries. Reducing the production of batteries will lead to lower mining activities that to obtain the metals required for the batteries. The mining activities themselves are what cause many detrimental effects to the environment. Therefore, lowering the reducing the mining activity is very important. Another way we get to reduce mining activity is by recycling lithium batteries, because the metals in high density batteries can be recycled and used to create new batteries an infinite number of times. One of the creators of the first ever commercially available high density battery is Akira Yoshino himself. Is Akira Yoshino. He said himself that the key for the future of electric mobility is in figuring out how to fully recycle batteries. He also admitted that the industry currently does not have the capabilities to do so. Now, with every commercially successful and widely used invention, there are negative impacts. While the high density battery packs themselves are environmentally friendly, The process of obtaining these metals, as well as the disposal of these batteries, can lead to negative environmental impacts. Firstly, the mining activities can lead to the contamination of freshwater sources with salt and chemicals. This is because lithium is mined from brine beneath salt flats. The mining of lithium can lead to salt. It can lead to salt running into freshwater sources. The purification process of lithium salt to pure lithium requires the use of highly acidic chemicals such as hydrochloric acid. Leakages from treatment plants can pollute the surrounding environment. Improper disposal of batteries, because of a low number of people recycling the batteries, also has negative effects for our environment. This is because batteries dumped in landfills can over time the chemicals inside can leak out and be released into the environment. Pictured here is a general breakdown of the metals used in lithium batteries. As I said earlier, most of these metals can be recycled to create new batteries. Although the exact composition of metals does vary between producers and the use of the battery. Pictured here is an example of a lithium mine. This lithium mine is in Kwinana, Australia.
Significant contributions of this invention for high-density battery packs toward the society with four different views, which is politics, safety, economic, and social. First of all, the economic. The high-density battery packs needs low maintenance. There is no periodic discharge needed and no memory. It also reduces costs and increases lifespans because of it reduced charging time. Lastly, it also flexible form factor. Manufacturers are not bound by standard cell formats with high volume, and reasonable size can be produced economically. Next is safety. It improves safety because it is more resistant to overcharge and less chance for electrolyte leakage. It also minimal temperature generations, ultimate performance and extremely long application with minimal temperature generations. For social, it's produce electric-based car. Society can live in a clean environment because there is no pollution from burning fossil fuel. The high-density battery pack also eco-friendly product. It protects the environment and the community can live in healthy and safely. Last view is politics. The high-density battery packs is a betterment of economy. It increased the ability of politics because the country's economy is stable. The high-density battery packs also has reusable battery. It is eco-friendly and do not need to spend more money for the battery.
The best solution to overcome any existence conflicts in high-density battery pack. First conflict is high-density battery pack are expensive to manufacture. Two challenges to the widespread application of lithium-ion batteries in electric vehicles are cost savings and improved energy density. Future cost reduction will rely on manufacturing and broader market acceptance. There are three important elements for cost reduction. First is the quality control to minimize scrap rate in cell manufacturing. Second, novel electrode processing and engineering to reduce processing costs and increase energy density and throughput. Optimizing cell engineering is a straightforward approach to increase cells energy density by increasing volume ratio of active materials in a battery pack. Next is the material development and optimization for lithium-ion batteries with high energy density. Another effective way to increase the energy density is to use electrode materials with high energy density. In order to increase energy density like lithium-ion batteries, it is desirable to find electrode couples with both high specific capacity and high operating cell voltage. For the next conflict of high-density battery packs is required protection circuit to maintain voltage and current within safe limits. Both legislation relating to the commercial shipment of lithium cells and batteries agree with the requirement that the cell or battery be packed in a way that prevents short circuit during transport. There are several methods to protect short circuit, include as pack each battery or battery power device in fully sealed internal packaging made of non-conductive materials such as plastic bags. Next, separate or pack batteries in manner to prevent contact with non-conductive caps, non-conductive tape, or by other appropriate means.
For the conclusion, the lithium-ion battery has clear fundamental advantage and decades of research which have developed it into the high energy density, high cycle life, high efficiency battery. Many suffer from the limited electrical conductivity, low thermal stability, and high volume expansion. As a new material and strategies are found, lithium-ion batteries will no doubt have an ever greater impact on our life in the years to come. Next, lithium-ion batteries have aided the revolution in microelectronics and have become the choice of power source for portable electronic devices. And then lithium-ion batteries are remarkable because the same fundamental technology can be used in many different applications such as medical device, cell phone, computer, power tool, drone, hybrid and electric car, bus, ferry, e-plant, and microgrid or home-based energy storage. While energy density is the most important factor for portable electronic, cost, cycle life, and safety also become critical parameters along with energy density, driving distance between charges for electrical vehicles. Next, for the recommendation, decrease gas and diesel car in favor of electric vehicles. Meanwhile, the rapid growth of solar and other renewable will require energy storage technology for effective grid-scale uses. So this is an example of electric vehicle using battery.